Hello, this is Mr. Buffington. We're going to look today at the basics of lines, what a line is, and how we can determine if a given point is on a line. So first off, what is a line? A line is a set of points that extend indefinitely in both directions. It's represented by a double-sided arrow, and like I said, it has an infinite number of points, and they're represented by ordered pairs x, y, where our x value is the first number, our y value is the second number, and they're all in a row, so we call them collinear. Here's an example of what I'm talking about. This is a line right here, so you can see it has an arrow on both ends, meaning that it extends infinitely in both directions, and you see the points here that are all in a row. You'll notice that all of these points, we could draw a line straight through them, which means they are collinear, and if you were to insert smaller points in between them, eventually when all the points connected, you would get a line. Now this does not show that it's extending forever, but you get the basic idea. Alright, so that is the basics of what a line is. The way that we write the equation of a line in a standard equation is ax plus by is equal to c. What that means is some number times x plus another number times y is equal to a third number. Here's an example. 4x plus 2y is equal to 6. That is one example of a standard equation of a line. Now, here's a type or a way that we can determine if a point, in this case 1, 2, is on the graph of this line. 3x plus 4y is equal to 5. What we do is we remember that the point 1, 2 is our xy point. So what we're going to do is substitute the point 1, 2 into our equation. 1 is equal to x, 2 is equal to y. And so it will look like this. It'll be 3 times x, which is 1, plus 4 times 2, which is y, our y value, is equal to 5. And then we solve that. 3 times 1 is 3, 4 times 2 is 8, and then we'll add them together. 3 plus 8 is equal to 11, and 11 obviously is equal to 5. Maybe not. Alright, so 11 is not equal to 5. And because 11 is not equal to 5, we can say with sure confidence that the point 1, 2 is not a solution for this equation, this linear equation. Right? The point 1, 2 does not satisfy this equation. It's a false statement. Therefore, and it will never be true. 11 will never be equal to 5. So therefore, this point will never be part of that linear equation. Let's do another one here. Is the point 2, 4 on the graph of the line 10x minus 3y equals 8? We're going to do exactly the same steps. We're going to substitute the point 2, 4. 2 is our x value. 4 is our y value. So we're going to substitute them into the equation. 10 times x, which is 2, minus 3 times y, which will be 4. Again, we get that point from up here. And we'll go ahead and solve. 10 times 2 is 20, minus 3 times 4, which is 12. 20 minus 12 is equal to 8. So our equation then at the end is a true statement. 8 is equal to 8. 8 will always be equal to 8, so that is consistently and always a true statement. What does that mean? It means the first equation that we solved, and they were different lines, but the first equation we solved for a point, and we asked, is that point on this line? And the conclusion was, no, it's not. It wasn't a true statement. It means that it was a point that is not connected to the line. There are infinite number of points that are not connected to this line. The second equation that we solved ended up being a true statement, meaning like this red dot, that point is part of the line, and therefore it was a true statement. So that's what we mean. When you're trying to solve for if a point is part of a line, that's what we're looking for. Does this point lie on the line? And that's it for the basics of lines and solving if a point is part of a line.